Hi everybody, we're going to keep talking about Gaussian elimination, which is section S.18. Okay, if you haven't watched the first part of the video, this isn't going to make any sense, so please go back and watch part 1 before we talk about this. Okay, so since you guys have already seen the method, we're going to jump right into an example. Okay. Okay, so here's our first example. So the first thing we're going to do is form our augmented matrix. Okay, so remember, each row corresponds to an equation, and each column corresponds to a variable, and then the augmented column corresponds to the solutions. Okay, so we have each of the coefficients 1, 1, 1, and then our augmented column has the solution 0. Okay, now remember this method is focused on getting it into the form where you have 1s on the diagonal, 0s everywhere else, okay, and then the augmented column will have the solutions. So we're going to focus on the top left corner, okay, and we're going to use division to get a 1 in this entry. Well, we already have a 1 in that entry, okay, so we're good there. So once you've done the diagonal entry, you're going to eliminate below the diagonal to get zeros, okay? And you're going to use this entry to eliminate these two entries, okay? So I'm going to do -1 times row 1, okay? And then I'm going to add it to row 2. So I'm not changing my first row at all. Okay, for my second row, I'm doing negative times this and add it to this. So -1 times 1 is -1, plus 1 is 0, right? And that's what we wanted. -1 times 1 is -1, plus -2 is -3. Okay, -1 times 1 is -1, plus 2 is 1. Okay, 0 times -1 is 0, plus 4 is 4. Okay, and then I'm not changing my last row. Okay, then I want to eliminate the other position that's below the diagonal, which is this one. So I'm still using this entry to eliminate below it. Okay, so again, I'm going to do -1 times row 1. Okay, and this time I'm going to add it to row 3. Okay, so I'm not changing my first row. I'm not changing my second row. Okay, and then I'm going to do -1 times this row and add it to the last row. So -1 times 1 is -1, plus 1 is 0, which is what we wanted. -1 times 1 is -1, plus 2 is 1. Okay, -1 times 1 is -1, plus -1 is -2. Okay, -1 times 0 is 0, plus 2 is 2. Okay. So now you guys can see that we have 1, 0, 0 in our first column. So the first column is done and we're ready to move on to our second column. Okay, so now we're focused on this position here. Okay, now at this point we would normally divide this position by -3. Okay, but look what would happen here and here, right? We'd end up with -1/3 and -4/3. Now since we're doing all of this arithmetic here and we're doing it all in our head, that's going to make it kind of hard. So here's a time where you might want to switch these two rows, okay? So that's actually what I'm going to do now. I'm going to switch rows 2 and 3. Okay, so I'm going to leave my first row alone. And then I'm going to switch my second and third row. Okay. So you can do that to avoid having fractions, because here now we will have a 1 in this position, which means we won't have any fractions from dividing. The other time you might want to do that is if you have a 0 on the diagonal, you want to switch the rows so that you don't have a 0 there. Okay, so now we have a 1 here. We're going to use this position to eliminate below it. Okay, so I'm going to do 3 times row 2, and I'm going to add that to row 3. Okay, so I'm not changing my first row at all. Okay, not changing my second row at all. Okay, and then my last row, I'm going to do 3 times this row and add it. So 0 times 3 is 0, plus 0 is 0. Okay, 1 times 3 is 3, plus negative 3 is 0, which is what we wanted. Okay, now 3 times negative 2 is negative 6, plus 1 is negative 5. Okay, 3 times 2 is 6, plus 4 is 10. Okay. All right. So now you can see in our second column we have 1 on the diagonal and 0 below it, which means we're done with the second column. Okay, so now we're going to move on to our last diagonal position, which is this one. Okay, and we are going to use division to make this into a 1. Okay, so I'm going to take row 3 and I'm going to divide it by negative 5. Okay. All right. So my first row is going to look exactly the same. Second row looks exactly the same. Okay, third row is divided by negative 5. Okay, so this is what I was referring to in the last video as kind of the first stage, right? So you start on the left and move across to the right, okay, where you've done all the diagonals, right? All the diagonals are 1, and everything below the diagonal is 0, okay? Then stage 2, you move back across from right to left. So we're still focused on this position, okay, and we're going to use this position to eliminate above. Okay, so first we're going to eliminate here. So I'm going to do 2 times row 3, and I'm going to add it to row 2. So my last row is the same. Okay, and then I'm going to do 2 times this row and add it. So 2 times 0 is 0, plus 0 is 0. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus negative 2 is 0, which was what we wanted. Okay, and 2 times negative 2 is negative 4, plus 2 is 2. Oh, I'm sorry, negative 2. Okay, and then I'm not going to change my top row at all. All right, now I'm still focused on this position, and I want to use this position to eliminate above it. Okay, so I'm going to do negative 1 times row 3. Okay, and I'm going to add it to row 1. Okay, so I'm not changing my last row at all. Oops. That's a 1. Not changing my second row at all. Okay, and then my last row, I'm going to multiply it by negative 1 and add it. So 0 times negative 1 is 0, plus 1 is 1. 0 times negative 1 is 0, plus 1 is 1. 1 times negative 1 is negative 1, plus 1 is 0, right, which is what we wanted. Negative 1 times negative 2 is positive 2, plus 0 is positive 2. Okay, so now we're completely done with this column. We have 1 and 0 above it. So we're going to move back to the left to this diagonal position, and we're going to use this to eliminate above it. So we're going to do negative 1 times row 2, and we're going to add it to row 1. Okay, so my bottom row is the same. Second row is the same. Okay, now my top row, 0 times negative 1 is 0, plus 1 is 1. 1 times negative 1 is negative 1, plus 1 is 0. 0 times negative 1 is 0, plus 0 is 0. Negative 1 times negative 2 is 2, plus 2 is 4. Okay, so now you can see we have the desired form where we have 1s on the diagonal, 0 everywhere else, and that means our augmented column is now our solution. Okay, so our final answer would be the ordered triple for negative 2, negative 2. Okay, let's look at another example. Okay, here you go. So the first thing we're going to do is form our augmented matrix. Okay. All right, and we're going to start in the top left corner as always. Okay, so we're going to use, first we're going to check that this is a 1. Okay, it is. And then we're going to use this position to get zeros below it. Okay, so I'm going to do negative 2 times row 1, and I'm going to add it to row 2. Okay, so I'm not changing my first row at all. Okay, so negative 2 times 1 is negative 2, plus 2 is 0, right? That was the whole point. Negative 2 times negative 2 is 4, plus 1 is 5. Negative 2 times 1 is negative 2, plus negative 3 is negative 5. Okay, negative 2 times 0 is 0, plus 5 is 5. Okay, and then I'm not going to change my last row at all. Okay, now I'm still focused on this position here, and I'm going to use it to eliminate this. Okay, so I'm going to do negative 4 times row 1, and I'm going to add it to row 3. Okay, so my first row is the same. My second row is the same. Okay, so here I'm going to do 1 times negative 4 plus 4 is 0. Negative 2 times negative 4 is 8, plus negative 7 is 1. Okay. Negative 4 times 1 is negative 4, plus 1 is negative 3. 0 times negative 4 is 0, plus negative 1 is negative 1. Okay, so now my first column looks good. I have 1 on the diagonal, 0 below it. So I'm going to look at this position. Okay, and I'm going to use division to make this a 1. So I'm going to divide that whole row by 5. So my first row will still be the same. My second row is going to be divided by 5. Okay, and then my last row is still the same. Okay, still focused on this diagonal position, and I'm going to use it to eliminate right here. Okay, so I'm going to do negative 1 times row 2. I'm going to add it to row 3. Okay, so now negative 1 times 0 is 0, plus 0 is 0. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times negative 1 is 1, plus negative 3 is negative 2. Negative 1 times negative 1 is negative 1, plus negative 1 is negative 2. Okay, so now this one has 1 on the diagonal and 0 below it, so we're ready to move on to the next diagonal position. Okay, and now I'm going to get this to be a 1 by using division. Okay, so I'm going to take row 3 and I'm going to divide it by -2. Okay, so now I'm still focused on this position. It's a 1. Okay, there's nothing below it. So now I'm going to start stage 2 and I'm going to start eliminating above this position. Okay, so I'm going to use this to eliminate here. Well, I can just add them together. So I'm just going to take row 3 and I'm going to add it to row 2. Okay. So 0 plus 0 is 0. 0 plus 1 is 1. 1 plus -1 is 0, right? That's what we wanted. 1 plus 1 is 2. And then my last row is still the same. Okay. And now, okay, I'm still using this position, and I want to use it to eliminate here. So I'm going to multiply row 3 by -1. Okay, and I'm going to add that to the first row. Okay. So 0 times -1 is 0, plus 1 is 1. 0 times -1 is 0, plus -2 is -2. 1 times -1 is -1, plus 1 is 0, which is what we wanted. 1 times -1 is -1, plus 0 is -1. Okay, and then I'm just going to copy my second and third rows. Okay, so now you can see on the diagonal we have 1 and there's 0 above it. So we're ready to move left to our next column. Okay, here I'm ready to eliminate above using that position. So I'm going to do 2 times row 2, and I'm going to add it to row 1. Okay, 0 times 2 is 0, plus 1 is 1. 2 times 1 is 2, plus -2 is 0. 2 times 0 is 0, plus 0 is 0. 2 times 2 is 4, plus -1 is 3. Okay, and then I'm just going to copy row 2 and 3. Okay, now you can see the left part has that form that you want, 1 on the diagonal, 0 everywhere else. So here's our solution, 3, 2, 1. Okay, all right, let's do one last normal example. Okay, so I wanted to remind you guys with this one that when you're making your augmented matrix, right, you have 2 as a coefficient for x, 2 as a coefficient for y. Now there's no z, you can't just put nothing, you have to put a 0, okay? And then in the augmented column we'll have -6. Okay, and it's the same thing here. We don't have any x terms, so you have to put 0 for x. Okay. All right. So we're going to start in the top left corner, and we're going to use division to make this a 1. Okay. So I'm going to divide the top row by 2. Okay, and then I'm just going to copy rows 2 and 3. Okay, so now that the diagonal entry is a 1, I'm going to get zeros below it. Okay, so here I'm going to do -1 times row 1. I'm going to add it to row 2. So my first row stays the same. Okay, so -1 times 1 is -1, plus 1 is 0. -1 times 1 is -1, plus -1 is -2. 0 times -1 is 0, plus 2 is 2. 3 times -3 times -1 is 3, plus 1 is 4. Okay, and then I'm just going to change, not change my last row and just copy it down. Okay, now because I already had a 0, 0, right, I have the form that I want, 1 on the diagonal, 0 below it. Okay, so I'm going to move to this column and look at my diagonal entry. Okay, I'm going to use division to make this a 1. So I'm going to divide that whole row by -2. And then I'm not changing my first row or my third row. Okay. All right, I'm still focused on this entry. Now that it's a 1, I'm going to eliminate below it. So I'm going to do -3 times row 2. I'm going to add row 3. Okay. So I'm just going to copy my first row, copy my second row. Okay. So -3 times 0 is 0, plus 0 is 0. -3 times 1 is -3, plus 3 is 0. -3 times -1 is +3, plus -2 is +1. Okay. And then -3 times -2 is +6, plus -5 is 1. Okay. So now I have 1 on the diagonal and 0 below it, so I'm going to move to my last diagonal entry. Okay. Normally I would use division to make this 1, but it's already 1. Okay. So now I have 1s on the diagonal, 0 below. I'm done with stage 1. I'm ready to move on to stage 2 where I eliminate above the diagonal. Okay, so I'm still focused on this position and I want to use it to eliminate above. Okay, so I'm just going to take row 3 and I'm going to add it to row 2. So I'm going to copy my third row. Okay, so I'm just going to add it. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus -1 is 0. 1 plus -2 is -1. Okay, and then I'm just going to copy my top row. Okay. Now, because of this pre-existing 0, I now have this column looking how I want it, right? 1 on the diagonal, 0 above. So I'm going to move to the left here. Okay, and I'm going to use this position to eliminate above it. So I'm going to do -1 times row 2, and I'm going to add it to row 1. Okay, so my last row is the same. Second row is the same. Okay, so -1 times 0 is 0, plus 1 is 1. -1 times 1 is -1, plus 1 is 0. -1 times 0 is 0, plus 0 is 0. -1 times -1 is +1, plus -3 is -2. Okay, now I have what I wanted on the left, 1 on the diagonal, 0 everywhere else. Okay, so here's my final answer, -2, -1, 1. Okay, I just wanted to remind you guys quickly why this is. Remember, these are the coefficients. So what you have here, right, is 1x plus 0y plus 0z is equal to -2, right? So if you reduce this, right, or simplify it, you would just have x equals -2. So that's why we have -2 here. And it's the same for the other two, right? You have 0x plus 1y plus 0z equals -1. Well, that just means y equals -1. Okay, so that's why you want this form, and it's also why this is the solution set. Okay, all right. Now let's look at an example of what can go wrong with this method and what it would mean. Okay. All right. So we're going to turn this. First of all, when you look at this, it looks totally normal. There's nothing unusual about this system of equations. We're going to turn it into an augmented matrix. Okay. And again, there's nothing unusual about the augmented matrix. Okay, so we're going to start on the top left. Use division to get a 1, already a 1. Okay, then we're going to use this position to eliminate below it. So I'm going to do -2 times row 1. I'm going to add it to row 2. Okay, so I'm just copying my first row. So -2 times 1 is -2, plus 2 is 0. -2 times 1 is -2, plus 1 is -1. -2 times -3 is +6, plus -1 is 5. -2 times 4 is -8, plus 2 is -6. Okay, and then I'm just going to copy my last row. Okay, so I'm still focused on this position, and I'm going to use it to eliminate the 3. So I'll do -3 times row 1, and I'm going to add it to row 3. Okay, so I'm just going to copy my first and second row. Okay, 1 times -3 is -3, plus 3 is 0. 1 times -3 is -3, plus 2 is -1. -3 times -3 is 9, plus -4 is 5. -3 times 4 is -12, plus 6 is -6. Okay, so now we have 1, 0, 0. We're going to move on to our next diagonal position. Okay, we want this to be a 1, so we're going to divide that row by -1. Okay, first row is the same. Okay, -1 divided by -1 is 1. Then I'll get -5 and +6. Okay, and I just copied my last row. All right, now I'm still focused on this position and I want to eliminate below it. So I'm just going to take row 2 and I'm going to add it to row 3. Okay, copy my first row. Okay, 0 plus 0 is 0. 1 plus -1 is 0. -5 plus 5 is 0. 6 plus -6 is 0. Okay. Now, it's at this point that you can tell something is very different than previous situations, right? We have this row of all zeros, so we can't look at this diagonal term and make it a 1. It's just not possible, okay? So anytime you have a full row of zeros like this, including the augmented column, okay, so this would be the last row is all zeros, including the augmented column. Okay. This means your system is dependent. Okay. Which means there are infinite solutions. All right. So that's one thing that can go wrong when you're solving like this. You're just solving normally, and then all of a sudden your last row is all zeros, including this entry here. Okay. That automatically means you have a dependent system and that you have an infinite number of solutions. Okay. Let's look at another example. Okay, there we go. So we're going to turn this into an augmented matrix. Okay, so we're going to start in the top left corner and use division to make it a 1. Okay, then because it is a 1, we're going to use this entry to eliminate below it. Okay, so I'm going to do -2 times row 1. I'm going to add it to row 2. So I just copied my first row there. Okay, so -2 times 1 is -2, plus 2 is 0. -2 times -2 is 4, plus 4 is 8. -2 times -6 is +12, plus 12 is 24. -2 times -12 is -24, plus 17 41. Okay. And then I'll just copy my last row. Okay. Now I'm still focused on this entry, and I'm going to use it to eliminate here. So I'm going to do -1 times row 1, and I'm going to add it to row 3. Okay. So I'm just going to copy my first row, copy my second row. Okay. And then I'm going to do -1 times 1 is -1, plus 1 is 0. -1 times -2 is +2, plus -4 is -2. -1 times -6 is +6, plus -12 is -6. Okay. -12 plus 22 is +10. Okay. Now I have 1, 0, 0. I'm going to move on to my next diagonal entry, and I'm going to use division to make this a 1. Okay. So I'm going to do row 2 divided by 8. Copy my first row. And then I'm going to divide by 8. Okay, now we are going to get a fraction here, but that's okay. Okay, alternatively, we could have switched these two rows and then divided by -2 if we wanted to. Okay, so we're still focused on this entry, and we're going to use it to make this a 0. So I'm going to do 2 times row 2, and I'm going to add it to row 3. So just copying my first and second rows. Okay. 2 times 0 is 0, plus 0 is 0. 2 times 1 is 2, plus -2 is 0. 2 times 3 is 6, plus -6 is 0. 2 times 41 over 8 is 41 over 4, plus 10. Okay, that's what I'm doing. And this is going to give me 81 over 4. Okay, so now I want you to look at the last row. Okay, you have 0, 0, 0 in the part that corresponds to the coefficients. Okay, and then in the augmented column, you have a number that isn't 0. Okay, now what would that mean? It would mean, right, 0x plus 0y plus 0z equals 81 over 4. So 0 equals 81 over 4. Now that's obviously false. Okay. And what that means is that there are no solutions to this. Okay. And if you remember our vocab from the first video about this topic, right? When there are no solutions, we say that the system is inconsistent. Okay. All right. This topic is mostly about practice, so make sure that you guys are practicing, and I'll see you again soon.